Hello everyone. So the title of today's lecture is functions. So in the today's lecture, we're going to study what are these functions. So let's start with the lecture today. If you can see here, what I have just described that this is the category under which this title comes, relation and function. And let's move forward. This I have just made a request in the very starting that watch the video till the end to get a good clarity on the fundamentals of function. This is the title of our today's lecture and it is part 1. And again, there are some prerequisites which are required. That is, there should be some prior knowledge which you should already have in order to get a good clarity on the today's title. And that prerequisite which we should know is what are relation. We should know this. We should know what are relations. So if you are watching this video directly, I suggest you first go through the previous videos which are there for relation. We should know this. Fine. And this is the outline of our today's lecture, that why we need these functions. After answering this question, we'll move forward with what are functions exactly, precisely by their mathematical definition. There are two ways, in terms of relation and in terms of arrow diagram. And third one is representations. What are the possible representations of a function? So this all we'll try to cover in the today's lecture. So let's start with today's lecture. One more request again, that watch the video till the end, and this is a new way of delivering a lecture today. So do drop me a comment whether this way you're liking good or the previous one which was there. Fine. So let's try to first answer what is this function, why we need them. So first of all, I would like to tell you that the title functions is very important, not only in context of this chapter but throughout whatever we're going to study, whether you are a student of class 11th or 12th or whatever, because in mathematics functions comes everywhere. If you see, if you have like gone through whether you do integration, whether you do differentiation, whether you study any other thing, function will always be there. So these are the fundamentals which we should know. So let's start with the motivation why it is required. I will going to answer the first one in just a single line, that functions can be understood as a tool. What we can understand functions as a tool. Functions are a tool for us. What it is, a kind of a tool which helps us describing or representing a real life or the real world. This is a good way. Real world in mathematical terms. Mathematical terms. I hope you got a clarity now. That what are functions? Basically, these are tools which we often, like, let me highlight it. Yeah. Functions are what functions? Functions are a kind of a tool for us. What they are? A tool which helps us in describing the real world in mathematical terms. In which terms? Mathematical terms. Because if we are able to analyze a situation, any situation which is going on in the real world mathematically, then we can make some good analysis over this. And this functions plays a good key role in helping us in doing so, whatever the situation we came with. Fine. So this is just a single line motivation, and in addition to this, there are a lot of applications of functions which you're going to know, maybe not in today's lecture but in the coming lectures, when I'll be discussing some good examples, top examples based on functions. So this is just a good starting which I want you to start with this lecture. So now move forward with the second question. What are functions? So Now we'll try to answer this. The second one. What are functions? Now again, to answer this question, you should already know what is a domain, what you should know, what is a domain, what is a codomain, what is a relation. All this you should know, and under relation you already know there is something called Cartesian product. You should have a good clarity of all these informations. So I'm assuming you know all these three. If you don't know, then go to the previous lecture or go through the video which are there in the information. So first we assume that we are given, like there is some given information. There is some given information. What is given to us? That there are two sets. Suppose that there are two sets A and B, and of course both are non-empty. A is non-empty and B is non-empty. Now, if I draw a geometrical interpretation of these, suppose like this. Let me choose a different color so that you can distinguish them. This is suppose a A, this is a B, and they certainly contain some element inside them. Let me call this element of the set A by A1, A2, A3 and A4. Suppose it contains 4 elements, and now I am calling in the set B, I am taking some elements B1, B2, and suppose B3. The set B contains only 3 elements. Now, how can I define my function? What is the basic requirement for a function? That we should have at least 2 non-empty sets, and now this function is nothing but a rule. What it is? It is a rule. And how this rule is defined? That corresponding to every element of the set A. This set A, if you recall, was a domain. What was this set A? If you have studied relations, then you should know that this was our domain and this set B was our codomain. Fine. So this rule says that every element of the domain will be assigned to only a single element of the codomain uniquely. Just try to listen it again, but I am saying that every element of the domain, what are the possible choices which we have? A1, A2, A3, A4. These 4 elements which we have. These 4 elements can be assigned to only one single element of the set B. That is, now I am using the term assign or assignment. What is the term I am using? Assignment. So let's try to understand this. This word is very important for us. Assignment. And how this rule, what this assignment means basically, this function is which is assigning these. Suppose, if you recall the relations which we defined, that in that there was something like that. Relation was this, R was collection of these ordered pairs, where this A is related to B, is related to B, and this A was coming from the set A and this B was coming from the set capital B. But if you recall that there were some situations in which this element A of the set A, capital A, was related to more than one element of the set capital B. But in case of function, what I want, that only my elements from the set A, if I take any element, can be related to only one element of the set B. And this kind of a special relation which we are defining is called a function. It's called a function. If now I relate my elements, suppose A1 is related with B2, my A2 is related with B3. These how I am using a kind of an arrows. I am relating them through these arrows. That's why such diagrams are often called as arrow diagram. So now if I write them in the form of the ordered pairs, I will write A1 comma B2 and A2 B3. But still there are two more elements left in the domain A3. So suppose I relate my A3 with B1, my A3 with B1, and finally my A4 with B2. And now I collect all these. So this is again a relation, but a special kind of relation which we have got, and such a relation is called a function. Such a relation is called a function. And if I use now some notation, small f, from this set A to set B. Observe now, this notation is very important for us. This is a kind of notation. This small f is a notation which I have used for representing this rule or this way of assignment of the elements of the domain to the elements of the codomain. So such rule is called a function. This f, in this case, is called a function, and if we try to understand it again, that what we have done here basically, now observe something, that my elements of the domain like this A1 is mapped to this B2, but this A1, I'm saying mapped. Now again try to observe what I have used without even defining. This map is nothing but an assignment where this small f is doing, and how this small f is doing, if I write it here over, this small f acts on this A1 and gives you B2. So this, it's a kind of another way of writing this assignment, how we have assigned this A1 to this is a A1 here, this is a B2 here. I have related these two using these arrows, and I have written these in the form of here this ordered pair, and if I call this my small f, this my small f is a collection of all those ordered pairs, and now this A1, which is the element of the domain, is related to B2 by this rule f. And another way of writing this ordered pair is this way, but I have just, if you see here, this is the another way of writing, and in this case we say that A1 is mapped to B2. What we say in this case, now try to observe what I am saying. Either we can say the first, how we can say f maps A1 to B2, or another way says f assigns, these are synonyms, f assigns A1 to B2. Another way of writing this, f sends, small f sends A1 to B2. Again these are repeating. And finally we can also say it like, this is the most important which I'm going to write now. Try to understand this one. B2 is the image. What B2 is? B2 is the image of A1 under the, now I'm going to use some different colors so that you can distinguish, under the map or under the function small f. You either use the word function or you use mapping, mapping, they are synonyms, so you can use any of the two. Fine. So this way we have just built a good motivation first why we require function, and then we have informally answered what is a function using the knowledge of domain, codomain and relations. So we can say, we can infer something, but we can conclude that from here a function is a special kind of relation. It is again a kind of relation, but a special kind of a relation in which what we have observed now here, I want you to just take a pause and try to identify what should I write after that, in which every element of the domain, in which every element of the domain that is the set A in our case. I'm just writing so that you get clarity. Every element of the domain is mapped or is assigned to a unique or to a unique or rather more to a single element of the codomain. So such a kind of a relation is called a function, and this again, if I write it like to give you more clarity again in terms of notation, that you can write the small f is a function. This for function you are writing these columns from the set A to the set B. You can use some different small symbols like small g. Here, like I have write set A and set B, there could be any two sets like B to D. What is the requirement? That these sets should be non-empty. What we require, what is important for us, that these sets should be non-empty. They should contain some element. Fine. So this is the requirement which we should know. So this is a kind of a definition which I have just given you. This is one way of writing a function. What could be another possible way? If can we say that if different elements of the domain are mapped to different elements of the codomain, then such a rule through which we are mapping those elements from the domain to the codomain are nothing but functions. So my function can be rewritten as a function is a rule or map, whatever you write, in under which different elements of the domain are mapped to different elements of the codomain of the codomain. Fine. What I am trying to say here, let's try to understand it. Suppose that we have two sets again. Let me draw them so that you can understand with more good clarity. Suppose this is your set A again, this is your set B. So this was your domain, this was your codomain. They contain some element. Let me mark those elements by, now suppose here A, B, C, and here suppose I call 1, 2, 3, 4. So what this, now again there will be some mappings. Suppose my A is mapped to 2, is assigned 2, B is assigned 1, C is assigned 3. So what this definition is saying, whenever you choose any two different elements from the domain, their images should also be different. That is, if I say in general, like if you try to understand this, if whenever this element of the domain, I try to understand this, if whenever x is not equals to y, x is not equal to y, now again where my this x and y from where they belong to the domain, they belong to the domain. Whenever x is not equal to y, their images are also not equal. What it means basically, you are mapping different elements from the domain to different elements of the codomain. No. It is something different. Oh, let me just note this. No. Fx can be same as fy. You see why? It was wrong what I just written, because if you see, now try to observe, there is something good which we can make an observation. In this particular case, if I now draw it again, this was my A, B, C, this is my set A, this is my set B, and this is my 1, 2 and 3. It might happen. What might happen? Now try to understand through the mistakes we learn. That what we require, that A can be mapped only to one element of the set B, but it is not saying that B cannot be mapped to the same element, or C cannot be again mapped to the same element. They all are mapped, but to only one element from the set B through this map F. So what it says, whenever your x is not the same as y, whenever your x is not same as y, these elements in general, I am calling these my, like here in particular I have chosen x, a, b or c. In general I am saying x is not equal to y. So their images if you look, that they are of course an element in this set capital B, but this small f cannot map this fx. It will not happen. Cannot map to suppose this. Let's try to understand this a particular case. Let me know this. Choose this function which we have just. Can I write now in terms of function notation that my small f is mapping the set element A to 1, is it's mapping B to 2, is mapping C to, sorry, it was 1, it was also 1, all are mapped to 1. So what the definition requires, that you cannot map this A, it will not happen that you map this to 3. If such thing happens, then this small f will not be a function. Why? Because it is the requirement of the definition that you can map the element from the domain to only a single element from the codomain. Fine. So let me take some examples of relation and ask you whether they are functions or not, so that you can get a good clarity. Let's take some examples. Suppose my relation R1 I am calling a relation 1, 2, 2, 3, 2, 4 and 3, 5. How I am choosing these are, suppose they are coming from some set, and what this means, that my first element are the elements from the domain, these 1, 2, 2, 3, that is, if I call the set A my domain, then 1, 2, 3 are elements from my domain, and the second elements are from the codomain. Let me use a different color. Yeah. If I call this 2, 3, 4, 5. So these, if I call this my B, so this set B, okay, yeah. So this set B, if you see here, the second element, collect all the second element, 2, 3, 4, 5. So this is my codomain. Now I'm asking whether this R1 is a function. Now the question is whether this R1 is a function from A to B. This is my question now to all of you, whether this is a function. I ask you to pause the video and try to think it once using the relation which is given to us. Try to think, observe the relation, observe the ordered pairs, you will get an answer. The answer is no. Answer is no, it is not a function. Why? If you just collect only these two ordered pair. Yeah. If we collect these two ordered pair, this one 2 3 and the next one 2 4. So what it says basically, your this R is R1, this relation is mapping, is assigning 2 to 3, and this R1 is again assigning 2 to 4. So this 2, which was an element from where it was coming, this set A, this set, and this set A was what? A is this domain. This set A is our domain. So you have chosen an element 2, which is here from the domain, and you are mapping this to two different values in the codomain. Yeah. And what we are doing is mapping to this to different values, which is not possible in case of a function. We can map it or we can assign it to only a single element from the codomain. So that's why this R1 is not a function. Fine, I hope you get clarity that this, in this particular case, this R1 was not a function. So let's go back to again what we have just covered and discussed today. Yeah. Okay, let's, yeah, not finalize. So if you see the outline, we have given answer to what was the motivation required, what are functions which we have defined over here. If you come, function is a kind of a special relation in which every element of the domain is mapped or is assigned to only a single element from the codomain. So such a kind of a function is, such a kind of relation is called a function. So, and the next, we have used arrow diagrams to, like such a diagram from the set A to set B was an arrow diagram, and this is a particular example which we have just taken now, whether this relation is a function or not. So it was not a function. So when, now again there is a question, when R1 will be a function, when R1 will be a function. Now this is a question. I asked you to pause the video and first try to think it. If now I answer this, this R1 would have been a function if in my R1 my ordered pairs would be like this: 1 2 2 3. Just eliminate one additional 3 5. This is my 5. Okay. So if you see here, all the elements 1 2 3 all are different from the domain and all are assigned to a single element from the codomain. So we remove this assignment. What we did, we removed this ordered pair from this relation R1 here, and we got a new relation. Suppose I call this now R2. So this my R2 is a function. What it is? It is a function. And how this will look like if I plot it? Suppose like this. These are my two sets. Then the first element, if I write it here, 1 2 3. If I write the second elements from the ordered base, 2 3 5, and I mapped 1 to 2, 2 to 3, 3 to 5. Using this rule, this R2, if I call this set A, if I call this set B, then this my R2 is a function from this set A to set B. Fine. So I hope you got a good clarity on the basics of a function. What is a function? If I now refine it just in a single line, the function is a special kind of a relation in which every element of the domain is assigned to a unique element in the codomain. Fine. So now the third topic is representations. What are the possible ways to represent a function? So let me now move ahead to the lecture and give you some more clarity on some good concepts of domain and codomain in those. This element, just one good remark which I want to quote here using some different colors so that you can get a clarity. Remark. A remark means there is something important now. Observation kind of what I get. That this, if I write my f of a equals to b, then this my a is an element of the domain this B is an element of the codomain. This, how we can also say that F acts, what F is doing basically, F is a rule which is acts on A and sends it to B. In this particular case, this B is called the image, but this B is called the image of A under F. Fine. And this small a is also sometimes called as the argument, or simply it is nothing but for us it is an element of the domain. What it is, an element of the domain. So these are some good remarks which I want you, because in different tests you might find some different ways of writing. So finally we will try to understand what are the possible representations. Let me now add a page. Yeah. What are the possible ways of representing? So what are the representations which we are interested in understanding? So the first was by an equation. So for the simplest case, suppose I choose this way of representing fx equals to x square. Now what I have just written is a way of representing a function by an equation. This equation is a quadratic equation, of course. So if you recall, if I want to plot it, just rub this first of all. Yeah, it's fine now. Try to understand. This is a good example now which I am just taking. Suppose this is your xy plane. What it is, xy plane. Now what this x is and what it is, this is very important for us. If you just understand this one, we'll get a good clarity on the coming one. This small x belongs to, this symbol means belongs to domain. Now domain of what? This function is f. So now try to observe something important what I am writing. Whenever I am calling a domain, so domain of a function. So in short, I'm going to write DOM for domain now. Domain of this function f. So x belongs to this domain of f. Fine. And this x square, if I call it y, what I call it? Y. So this my y belongs to this codomain. Y belongs to this codomain. And now just let's first try to understand this example, and I'll give you more clarity on that. Now what is the x what I can give or put or give it in, what are the input values? Basically this is my x is an input values. What are the values this f can take using this x? So this my x has the choices. If I call this my x, this is my y-axis, this is my origin. So all the values here lying on the x-axis, all the values lying over here, these I can insert in this here. In this, these all are the possible ways of substituting in these x values. Fine. Why? Because your parabola, this, if I plot it, suppose let me plot it to you. If I choose my x equals to 1, then my f of 1 will be, substitute x equals to 1 square, which is 1. So if I call it here 1, then this height is also, this height is my f of 1, which is 1. This is same. This is the point. Like this is the value for your x, and this I was calling it my y. So this y is also 1 in your case. Your ordered pair in xy plane is x comma y. So this is 1 comma 1 in our case, which I have just plotted here. Fine. If now I choose my x to be 0, what I choose? My x to be 0. This is the element of the domain. observe, which you are inserting. I'm using a different color. Now this, try to distinguish so that you can get a clarity. This 0 is an element of the domain, and now I will use a different color because unfortunately in this all the cases the values are same. I will use some different value of the domain so that you can also get clarity on this. If now I got the answer 0 square, which is 0. So this 0, which is an element of the domain, and of course this 0 where it belongs on the x-axis, and this 0 is an element of the codomain. From the answer which we are getting is an element of the codomain. The 0 belongs to codomain, or the 0 belongs to the y-axis, the value. Fine. F of 1, f of 0 in this case it was here, and this values are here. So you choose. This is the point which you are going to represent, because your order pair is again, let me write this, x comma y, and so it is 0 comma 0 in our case. If you can easily see it, 0 comma 0. This 0 is this 0, this x, and this 0 was your this one. Fine. So that's why this is my point which I just plotted over here. Similarly, if you choose your x to be minus 1 here, then you can easily see that your f of minus 1 is simply minus 1 square, which is 1. So this is now ordered pair which you are going to represent is minus 1 comma 1. So this height will remain the same over here. Height is same. This one is same. Let me rub this because you cannot fix f of 1 because they are, if you have just observed here, the same height you have assigned to minus 1 also. So the height which you are getting is same throughout. This value will be going to same for any value. Like here on both the cases, in this case also, in this case, you get the same value. Fine. So the values which you are getting are your images, and they are part of the y-axis, and your y-axis in our case is the codomain, but this is the codomain, and but this is the domain. Your x-axis is the domain of the function small f, and I have represented, like I have just sketched only 3 values from the domain. If I now try to plot it, you know, it will going to look something like this. So this kind of function which you are getting is a parabola. What this called is a parabola. Fine. And this is the way of representing this. This is this equation. This is just one way of representing a function. So this curve you are getting is nothing but the function, and if now this f is again a map from my x-axis to my y-axis. So this x-axis is domain, this y-axis which you are getting in terms of values is your codomain, and now the third more important concept of range of f. This is very important. Range of f. Range is nothing but collection of all those images. You collect all the images which you are getting by substituting x. X was coming from the domain, and the domain in our case is capital X here. Fine. So I feel that we can stop the today's lecture because and continue the outline in the next lecture, because it will be so much for you to understand. So what I want that first you should grasp whatever which we have covered today. Just we try to revise whatever in short what we have covered with a just quick summary. So this function is a tool which we use to understand real world problems in mathematical terms, and how we have defined function using 2 non-empty sets A and B, which are the first non-empty, they contain some element. The set A was called the domain, the set B is called the codomain, and what this function says that you can assign only one element of the domain to a single element from the codomain. So it's a special kind of relation in which only a single element is related to the second element. Fine. These are possible ways of writing this function. function maps, assigns, or sends. This element which you are getting from the codomain is called the image of the element from the domain. This was the definition, and this was just an example in which case, in the first case, your relation was not a function because you are mapping the element 2 from the domain to two different elements from the codomain, and which is not possible in case of function. And this was how we removed the second assignment and we got a new relation which is a function R2. Fine. So we conclude the today's lecture with this much of information, and we'll be continuing more on the functions in the next part 2, and do find some relevant links given in the description, and do share about our initiative among your friends. Do subscribe to the channel. Thank you so much.